Okay, let's move on with the account sections. We'll just quickly take a look through some of these endpoints here. So we've got get transactions. That is just simply going to provide a list of all of the transactions from the user for the specific filter options that you put through, which we'll go through together. Get native balance. Now that is specifically to do with Ether. That is a native balance from the Ethereum network. BNB is the native balance from the Binance Smart Chain. Okay, so they are different to token balances, which is the next one. So token balances would be ERC20 tokens. And so that would be things like your chain links or USDCs or whatever else you might have on the Ethereum network, or other tokens, for example, on other blockchains. Token transfers makes sense. It's to do with your ERC20 token transfers. Get NFTs. Now that's different to token balances because NFTs are ERC721 or ERC1155 tokens, not ERC20. So getting NFTs will simply provide the NFTs from those particular token types. Get NFT transfers is the same thing for the transfers, and get NFTs for contract. Now that's something that's just a bit different because this one will return an object with the NFT count for the specified contract and an array. So the main sections that we're going to be looking at here will be transactions as one section, balances as a second section. So that will include native balances and ERC20 balances separated. And then NFTs would be the third section. Okay, so we'll build all of that into the dashboard application, which we briefly looked at in the previous video. So on the left-hand side of this application, let's just run through. We've got a menu of the different options available in this wallet: transactions, tokens and balances, NFTs, and the Web3 API token section, which is the next video. Further down, we've got the transfer section, which we covered in a previous section of this course, where you can send Ether, you could send ERC20s, or you could transfer NFTs. So I'll show you how that also comes to life as well. And then a bit further down, there is this section which is not going to be in this section of the course at all, which is a portfolio tracker that you could build. That would be a great project for you to build. And then building into our plugins, for example, buying a crypto with fiat and also swapping tokens, which would be the sort of decentralized exchange idea. So that would come later on. Let's refresh this application and let's start from the beginning. So that will be under transactions. So if we go back to the documentation and we'll go back up to get transactions and reading from the documentation, it returns the transactions from the current user or address, and it returns an object with the number of transactions and the array of native transactions. It's asynchronous, so wrap it in an asynchronous function. And then you can pass it any of these options if you wish to. There are some required ones. For example, you'd need to provide the address for the user. And ideally, you'd want to provide the chain as well. Otherwise, it just defaults to Ethereum. So for example, if we go back to the dashboard here, I'm actually logged in to an account on the Rinkeby chain. So if you don't include a chain, then it will you'll get the wrong information from it, and that might confuse you. The address is required. So you can put in your own Ethereum address or anybody else's Ethereum address if you wish to. And if we go back to the documentation, we have the from date and the to date, the from block and the to block, an offset and a limit. So if we go back over here, so let's choose Rinkeby. The address, just go and choose your own ETH address or copy one in. If you're not sure what your own ETH address is, you could utilize a simple function like this one, where you just goes and gets to your own ETH address. The date range, I've put a date picker in here, so I'll just maybe choose this to this. And behind the scenes, I've just converted that, and we'll leave these ones empty. We'll click Get Transactions, and normally it just returns an array and an object, and then you'll need to go and find a way of handling that data, and I've done so with this. So these link off to Etherscan. And I've also shortened the transaction hashes as well. The block number also goes off to Etherscan. And again, that's based on the network that you choose here. Depends on whether it goes to Etherscan or BSC scan or whatever it might be. The age is the age of the transaction. The outgoing is whether it's coming in or going out. The fee that was paid and the value of the transaction. So that's the information that you'd get. And so this is the filter function here. And so you could even choose it by the block range, for example. So I've only got about sort of 8 or 9 different transactions in this list, but maybe we could go back to the block. So 9.3 million, maybe up to maybe 9.6. And then if I get transactions, it should give us more. There we go. All right. that goes all the way back to 9.3, and perhaps there are transactions that are older than that even still. There are. Okay, so that's how you would use the filter function, and what it would be. The offset just simply would offset that, so you could maybe put in an offset of 10, and it will just chop off some of the ones from the bottom there. You could limit the amount of results that you'd get as well. Say 5, and then it would do that, and then maybe you could do an offset. So that is the transaction. Okay, what's next? Get native balance. So what you should just be aware of here is that you'll generally have native balances and ERC20 token balances, and they are different. So for example, on the Ethereum blockchain, the native currency is Ether. Not an ERC20 token as such, it's the native balance of the Ethereum network. Be aware of that. It would be the same on, for example, the Binance Smart Chain. The native balance would be BNB. So that's why we have these two different endpoints here. So for get native balance, typical example of that would be over here on the left-hand side of our menu. Our native balances, if we just click on that, it's going to go and search all the different balances that we have on the different networks. So it's done a search for Ether or Ethereum network. It's done a search on Ropsten, Rinkeby, Gurley, Kovan, Matic, and so on and so on and so on. It shows how much you've got. Now in this particular application, I've also got a transfer function here. So it will block out any of the networks that you're not logged into. And then obviously it highlights the button that you can transfer. I've not connected that function, but you'd be able to do that if you wanted to just send you over to the different section of the app. So how does that work? Well, if we go over to the documentation, we have 4 different options that we can send into this function. One of them is required. That is the address for which you want to be searching for. We have 2 options that are available in the documentation here. One is just a single line of code. So the variable balance just awaits moralis.web3.account.getNativeBalance with nothing passed in. Just be aware that that may now fail because you do require the address as a parameter inside that. But give it a try, see what comes back. And if it fails, then that's the reason why. It's saying the address twice here, but they've now moved. The reason they've added it is because it's now a requirement and not an option. And the second option is something we're more familiar with, as in we have the same line of code, but as inside that function, we're passing the options object, which we need to build. And the 3 options in that case then can be passed through in that options object. The result that you'll get back is simple. It just provides you with the balance. If you want to search for Ethereum and your, all of those individual balances like I've done here, that will require you to make 8 separate calls for those. You can't pass through an array. You'll need to provide each individual one. But most of the time, you're only going to want the balance of the person that's actually logged in to the application. But most of the time, you only want the balance of the user that's logged in to the chain that they are currently logged into. Okay, so that is native balances. Let's move down. Okay, so get token balances. That is specifically talking about ERC20 tokens or equivalent, depending on the network, and it will return an object with the number of tokens and an array of the token objects. So let's go and have a look and see what that would do. If we go, for example, into this one, so your ERC20 token balances, let's see what it provides back. This provides a table. It shows 3 particular tokens on this network. So I've got Zenus, Venus, and Chainlink token. Now, I'm logged into a Rinkeby network, so none of this is real. And the additional information here comes from the metadata of these particular tokens. So I've got Zenus as the name, I've got Zenus symbol, how much balance is in there. It actually says 12 ETH, but the symbol itself should probably be used instead. And then the number of decimals and the contract address. So that's potentially pretty useful. So over in the code, I've just gone down to the HTML section of the application, and inside the accordion, because that's what that is on the front end, I've found the ERC token balances, ERC20 token balances. And I've already hard-coded in just a basic table header and an empty table body, which I'll inject content into from the JavaScript. And in the JavaScript side, the function itself does a few things. Now, I've written a function here called getNetworkText, which is going to utilize a WEB3 function in order to go and get and return the chain ID. So I've had to initialize WEB3, and then I have called to get the chain ID and return that back to this function here. And then by using the chain choice, That's what I'm passing into my options object within the Moralis function. So my Moralis function is tokens, and I'm just going to await moralis.web3.account.getTokenBalances. I'm going to pass it the chain as an option, which will be my chain choice that comes back from this function. So whatever chain I'm logged into on the front end, Rinkeby in this case, it will pass back from that function and put it into my options object. And I'm also going to pass it an address as well, which will be the ETH address. And what I've done is I've initialized an ETH address variable and I've left it blank. And I've got an if statement here to handle whether or not a search item has been entered in here. Because if somebody wanted to put in a different Ethereum address, for example, they could put that in there and that's what would return. Otherwise, it just uses the default one for whichever one the user has got. And the rest of this function is just handling that data in HTML. I would probably do this differently if I could refactor it now, so make it more compatible with a React component. So I'll just simply render it a slightly different way and not use this .inner HTML. But this had the effects that I wanted when I was building it in Vanilla.js. Okay, so I actually only used 2 options in my options object, and that meant I didn't use the third one, which was this toBlock. So the toBlock, the reason that that's useful is that you could go back to any specific point in time and check what the balances of that particular user had at that moment. So that could be good for record keeping or doing tax, for example, or auditing, whatever it might be. You know, that could be a useful feature for you. Now, I've already handled the data and put that into the application like this. But if we go into the console here, we console log out some of that data. This is the type of information that you get back. This will be the object itself, so you can see the balance, decimals, logo, name, symbol, thumbnail, and the token address. So I've just taken the information that I wanted and put it into this table here. And there are 3 objects because there's link, Venus, and Zenus. So each one of these 3 objects would be the different tokens. Let's close this. Let's go back to the documentation and let's move down. So now we have token transfers. Getting the token transfers is very similar to getting transactions. The difference being that transactions would take into account everything: native balances, ERC20 token transfers, and also NFT transfers, whereas this one specifically looks at getting the ERC20 token transfers only. That's from the current user or the address that you use. It returns an object with the number of token transfers, and it's asynchronous. You also have another sort of 8 options that are available here to help you build your options object. And the documentation shows 2 options that you could use. So you could send through the single line of code without any options, but that might fail if you don't have an address that you're sending through. I remember that the address parameter was going to be used in the majority now. So if that's the case, just send through an options object like you're already familiar with. You don't have to send through all of them. The majority of them are optional, but get into the habit of always sending through an address. The example result would look like this, which is less detailed than the options object that you get back from get transactions. Looks like this, a lot more information in here. But that's because sometimes you're looking at different data, because you might be looking at a different asset. So that is for get token transfers. And let's go and take a look on the front end. Again, just super simple user interface here with drop down. So again, we'll just choose Rinkeby, then paste it in there. And let's see if that gives us anything. So we'll just go, oh, it does. Okay, great. So in this results table, it's pretty similar to the transactions table. I've got a from and a to here, rather than a few of the other options in transactions. It doesn't show what the token was that was transferred, but if you clicked on the transaction hash, it takes you over to the relevant scan site, and you can see that this one was Chainlink, which is ERC20, of course. The next one down was Venus, again, ERC20, and so on. So inside of the result object, you'll have some information that you could use to go and find more information about it. And that's how I did it in my application. So I checked the network that you're on, Rinkeby, and then handled the link for the transaction hash based on the network that you're on. All right, so that is to get the token transfers. So we've covered the transactions, we've covered native balances, and we've covered ERC20 tokens. Let's move over to get NFTs. It does exactly what it says. Now it's going to get all of the NFTs from the current user or address. It supports both ERC721, which is fungible, and ERC1155, which is semi-fungible, if you remember from the previous videos. And it will return an object with a number of NFT objects and an array of the NFT objects. It's asynchronous, so put it inside of an asynchronous function. Now I've only got a couple of options here. Again, address, always recommended that you put that in, and chain, if you don't put one in, it will default to ETH or Ethereum. These three examples that you can see on the documentation here, the first one is just running the function with no parameters included. It may fail if no address is included in there. But the second one has a chain of Ripston. Again, it may fail if there's no address in there. And the third one is more familiar to what we're used to. We build an options object, and then we call the single line of code with that options object included. And the single line of code is moralis.web3api.account.getNFTs. Okay. The example result would look like this. So the output, for example, here shows the information that you'd get from that. It's not particularly user-friendly, so you would just maybe build a for loop that cycles through each one of the tokens that you get back from your function, and then it renders, let's say, the metadata onto some sort of card, bootstrap card in the front end, and then it just makes it easier to use. If we go to the front end of the dashboard and go over to our NFT section, for example, and let's just take a look on Rinkeby. Let's go and grab my own address and then get NFTs here. And then, there you go. That's the example that I had in mind. So you would have just some cards. It renders through. There are 5 NFTs in this particular account. And then it just goes and renders the metadata of each one of those and passes it through. Let's see if it... There we go. And we can see that we have the 5 different objects from each NFT. And inside those objects, you've got that information. So you can see here that there is metadata. Now, the way that I resolve the metadata is to run a JSON.parse. So let's go and take a look at how we use the metadata in the code. This is the getNFTs function. First 2 lines are just collecting the information from the front end. This line actually doesn't have a separate options variable. We've just put the options object inside of the function call. And then the rest of getNFTs function here is just about using the data. So we have a loop. We are running through all of the NFTs, and for each one of them, we're running some HTML. Again, you could render this a slightly different way, but to get the metadata, I've just gone within each one of the NFTs .result. I have done a JSON.parse around that. And then with that data, you can then call it inside of your template literals and render it into your front end. So this is with vanilla JavaScript, but in React, you'd be utilizing your props when you're building your components. So you would just do it slightly differently. And that's it. And then I've just simply rendered it to the front end with that information, which gives us this. Okay, good. So that is how you would get your NFTs. Let's go back to the documentation. Okay, get NFT transfers, the penultimate endpoint here in this section. That's what it says. It gets the NFT transfers and it returns an object with the NFTs, an array of the NFT transfers. You will always be passing it an address and the chain that you want to search. Otherwise, it's going to be ETH. Now, the rest of these, some of them might be new to us. We've seen offset before and we've seen limit before, but what we haven't seen would be the order, the direction, and the format. So format is quite simple. It just is related to the format of the token ID. So when you get response back from this function, you'll have the token ID here. This is an example of decimal, but if you choose hex, then it would look something more similar to, well, maybe not this because that's quite a high number, but you'll see something that is going to be a relatively larger string. Direction. Now that decides whether it returns both incoming and outgoing NFT transfers, or only ones that you've sent out, or only ones that you've received. When I say you, I mean the address that you've used in this search down here. Okay, so that's the direction. The default value is both, so it'll just return incoming and outgoing transactions. And order. Now, this is something that might throw people off a little bit. Now, order, you can choose a number of ways or fields from which to order it in. So for example, the result is going to be this. And these are all the fields that you can sort by: token address, token ID, so on and so on and so on. Perhaps the most common way of sorting is going to be by block number, because that's just, it's sort of date related, and it would be sequential in some way. But what you're going to do is you're going to be passing through the option of order, and it would be the field name followed by whether it's ascending or descending in capital letters. So if I just show you in a piece of code, let's go and take a look at this on the front end. And if we head on over to the NFTs and scroll down to NFT transfers, again, I've just put all of the different options that are available here into input fields. And so we'll just choose Rinkeby. We'll just go and get my address. Maybe I'll just limit this to 6. And I think I remember putting all of this where when we call this function, it's going to dump it all into cards directly underneath this button. So let's just call that, see what happens. That's the data, or that's the object, options object that I've sent through to the function. And this is all of the data from the search. It's quite small, but you can see all of the details. And I'm just looking at the first 3, for example, because I want to show this order field here. So if I just look at block number 620, 920, 930, 920, so they're not ordered by anything at the moment. So if I just put in block number into this order option, that's not enough. We would also need to then put whether it's ascending or descending by appending the .asc or .desc directly after it like that. And then once you click on search, give it a second to do what it needs to do. And after it catches up, you can see that now it's ordered. So 919, 919, 919. So all 6 of those are now ordered. We're only bringing in 6, so all of the others are not going to be there. You could change the offset if you want to pull in different results. You could also probably refactor the code that I've very crudely written in this particular function, because in here the majority of the code is just HTML management. I've pulled in all of the data from the input fields. I built my options object with those input fields, and then I pass it in. I've console logged the options object, but you pass it into the function moralis.web3api.account, .get NFT transfers, pass it the options object, and from there you then handle it. So I've just pasted it with a for loop, gone through everything, and I've used object.keys to go and for each one just put that information into a card basically. So again, you can probably refactor that and do it a slightly different way, but that's how I did it in this example. And that is how you would get information back from the get NFT transfers endpoint, but particularly I just wanted to highlight that order. Okay, and then finally, we will head back over to the documentation and finish up with get NFTs for contract. It returns an object with the NFT count for the specified contract and an NFT array as well. There are a number of different options. We're familiar with most of these now. The standard ones, chain and address, we're already familiar with. We have order, which we briefly looked at before as well. So just make sure whichever one you choose, whichever field you want to order it by, you just put .asc or .desc at the end of it. We've got the offset and the limit. We've seen that before. And the format, that's based on the token ID as to whether it's decimal or hex, same as previously. Token address will be the address for where the NFT currently is right now. So the address of the contract. The build is exactly the same as usual. You create an options object with any one of these options that you want to use. And then you feed that options object into moralis.web3api.account.getNFTs for contract. That is it. Now, this is interesting here because sometimes you might search for a particular NFT and it's not been indexed yet. So any request, which includes a token address parameter, will start the indexing process for that collection for the very first time if it doesn't already exist. So that's good. And the output would look something like this. If we go over to the front end, take a look. Again, I've just put the options or the inputs into these front end options, and I've got a couple of things we can use here. This is a Matic example where we can use a user address and we can use a contract address. I've just copied and pasted the user and the contract into those 2 fields here, and it says Matic, so that's Polygon. So let's put that there, and then we can put get NFT transfers. That will probably be in the console log. Let's go and have a look. Here we go. There's an object that's returned here. The object at the top, I believe, will be the options object that I've formed. And then the response will be this one here. And it only has one that's come back. But inside there, you will find it's an ERC 1155 from OpenSea Collections. So go and feel free to take a look into different ways of playing with that particular NFT endpoint. The code for that particular function, super straightforward. Get NFTs for contract. The majority of the first half is just building the inputs from the front end, then building the options object, console logging the options object, single line of Moralis code to get the information which is stored in the NFT data. And then with that, it would then, you could handle it and pass it over to the front end like this. Again, it's just put it into a card, but you might want to render it in a different way. And that's it, guys. So that has taken a look at the transactions, the native balances, the ERC20 token balances, NFTs and NFT transfers, and how you would use the Web3 API to pull in all of that information, in most cases with just a single line of code once you have built the options object. I hope my explanation has helped explain to you what some of these parameters are and how you can use them. And I really look forward to seeing how you're going to be able to build these into your application and recreate and refactor this dashboard. In the next section of videos, let's take a look through the next section in this API documentation, which is the tokens. Join me in the next one.